Yes, good afternoon. And I'm going to go through some OpenFlow and P4 Runtime and P4 applications, some real live examples of products that we have implemented with focus on the OpenFlow and P4 technologies that we used. So starting, just a few words about Noviflow. There's just one of these corporate slides. So we were founded in 2012, and we joined ONF in 2013. So we've been a member all along. Our focus is using SDN to optimize networks and the edge of networks. The product, we have networking software, NOS for WAN and also applications for cybersecurity. And I'll explain a little more. And the way we deliver our products, our business model is to license our software and sell solutions. And we very early on, the company was spun out from University in Montreal as a pure OpenFlow company. And our first OpenFlow 1.3 implementation we released in second quarter 2013. And the core technology that we built, the silicon we built it on was network processors. But now more recently, we've been working a lot with Tofino as well. So let's start with what's core in our view of the world and our technology, and it's this match action pipeline processing and the ability to program it. And on the left, you see traditional ASIC match action pipeline. You have a fixed set of tables. In each table, you can match on a certain thing. You can do certain actions, but the packet essentially has to go through this pipeline. And if I'm the application programmer, what I have to do is I have to try and fit my application into that given match action pipeline. One example of this is OFDPA, and then on the right hand side is imagine you could start from scratch. Have nothing pre-defined in the silicon. And you as an application programmer then can, from the very start, define your match action pipeline to fit your application. And you would basically put in the tables and the rules to drive your application. And that's, what was called a top-down programming paradigm. You let your application drive your pipeline. And that's really where we have focused the company. If a application programmer could use a fixed ASIC, they should just have gone ahead, right? But if the application didn't fit, that's when Noviflow was able to provide value. So why do you want this programmable match action pipeline? And there are three headings here. Of course, the first one is fast introduction to networking functionality in protocols like VXLAN, INT, SRv6. And also you can quickly prototype new functionality or new capabilities. The other thing is your features and the functionality is defined in software, not in hardware. So your hardware platform, there's really no forced obsolescence. You can evolve your hardware as you need new functionality in your network. Or you can repurpose your hardware in a different, to do something different. And then the third thing is, you want this disaggregation of networking hardware and software. And if you also have this software that defines the functionality in the silicon, your application isn't locked into a specific networking hardware. And of course, we've been a strong proponent of this separation of control and data plane so that you can scale them independently. So here's a sample implementation of and I'm starting with OpenFlow, and then I'll show how we have evolved to P4 and P4 Runtime. So the picture on the top right there should be familiar. It's the basic OpenFlow match action paradigm. You can have n sets, n tables, and in each table you can match on something. You can, take certain actions and instructions, or instructions and actions. And in its pure form, OpenFlow 1.3, 1.4, 1.5, they provide the application programmer really a programmable match action pipeline. You can define how many tables and etc. And that's essentially what we built. We built a solution around network processors that allow the application programmer to define up to 60 tables in TCAM for wildcard matching, and up to 60 tables in DRAM for exact match. And we implemented, in the OpenFlow 1.4, we had every single of the 41 match action, of the match fields. We had all the 6 instructions that's defined, and like 50 some actions defined. So it was really a very rich tool set for the application programmer to define the pipeline that they wanted. And then I would say also the number of match fields and the actions available, and it evolved over time. I think it started with 12 fields in OpenFlow 1.0. By OpenFlow 1.4, we had 41 match fields. But it made the protocol, all of these things bubbled up through the protocol. So they were defined it was really protocol dependent. But then there was another facility too I want to highlight, and this is experimenter extensions that allowed companies to innovate. So you could create your own experimenter match field actions and more. And I'll show you some examples. Over time, from 2013 up until this year, Noviflow has been adding more and more of these experimenter extensions to fill the gaps in the OpenFlow specification that our customer identified. And if you look in the list over to the right, you see INT. We actually implemented INT in OpenFlow, so we have OpenFlow experimenters to allow you to do INT. Lots of encapsulations like L2GRE, STT, VXLAN, L2 MPLS, and they all have specific use cases that our customers were pursuing. And I would say we pushed the experimenters to the limit, right? And in all kinds of areas, like broadband access, MPLS WAN, data centers, all kinds of use cases that our customers are using this for. So that's really the OpenFlow story as it evolved. The problem though with this was if you created an experimenter and you wanted an ODL controller to use it, we actually had to write software for that ODL controller to enable that experimenter. The same with ONOS. So it bubbled all the way up all the time. And yeah, so now going over to P4 and P4 Runtime, and this is trivial, right? I just want to point out the difference. The P4 is the language that is a domain-specific language that allows you to define how to process packets. You can program the parser, you can define the actions, the tables, etc. And then the P4 runtime is the interface between a P4 controller and a P4 programmable switch. And this is more similar to OpenFlow. It allows you to load the compiled P4 program into the switch and then add and delete flow entries in the match action tables and then collect statistics from the switch. But it's still the separation of control and forwarding using P4 runtime. So for us, this was right in our wheelhouse. So what's the big difference that we've seen between OpenFlow and P4 runtime? So both of them gives the application programmer, this programmable match action pipeline. They can define their pipeline and then develop their application for that. But then P4 runtime additionally has two things. And one is P4 allows you to program the parser. And this is new. In OpenFlow, for us to add a new match field, we have to build an experimenter into the protocol. With P4 and P4 runtime, it's inherent that you can parse the packet in a different way, or you're allowed to parse the packet in a different way. And so that's on the match fields. And then, of course, on the actions, too. In OpenFlow, you were constrained by a certain number of actions and instructions. But in P4, you could create your own actions. And then there's always this little asterisk, right? So we were able to do a lot of this with the OpenFlow experimenters, but it wasn't inherent in the technology, as you saw on the previous page. And then I just want to have one slide. When you look at, we're talking about OpenFlow and we're talking about P4 runtime, and in a NOS, that's really just one component. There are many other things that you need in a NOS, like configuration management, operations, security management, extensibility, telemetry. So we're talking about these facilities to program the forwarding plane and So how did we then, Noviflow, go from OpenFlow? We had been in OpenFlow for 5 years, built a really nice OpenFlow engine, forwarding engine. How did we start working with P4? And so what happened was we discovered, Barefoot Tofino at the time, and suddenly had another silicon that was very, very programmable. And so we thought, and at probably roughly 10x the throughput and 1/10 the cost per gigabit per second. So we said, this silicon, how can we make this available to our customers? So the first thing we did was, and this is phase one, we put OpenFlow on top of P4. So we basically wrapped OpenFlow around P4. So with OpenFlow 1.4 support, we did 40 out of the 41 match fields, 5 out of 6 instructions, 67 different actions, including a lot of our experimenters. And this allowed our customers to use this white box, Barefoot or Tofino white boxes, and use them as OpenFlow devices in their networks. The target was initially to scale, customers, to give them a much more cost-efficient solution, high bandwidth solution that was still this they could use with their OpenFlow controllers. And the way we did this was within Noviflow, it looked like an OpenFlow switch, but we took that OpenFlow and turned that into P4 programs. We auto-generated P4 programs, compiled them, and pushed them into the silicon. And then you could then add, delete, modify flow entries in that pipeline. So in that process, we gained a lot of expertise in P4 programming as well, because we had to map OpenFlow into P4. So, but that was our first phase. We released it March 2018. It's in production. Big operator has this in production in their global network and also their national network running open. So that was phase one. The next phase was to allow native P4 in our NOS, in the Noviflow. And so instead of being able to program the switch or the pipeline in the switch through the OpenFlow paradigm, we now allow our customers to load any P4, compiled P4 program into the switch. So they can create a pipeline that's independent of any constraints based on OpenFlow. And then, of course, the way you control the switch is with P4 Runtime. That allows you to ingest P4 programs, configure the pipeline, add, modify, delete flows, get counters, etc. And what you do is, at the start, you say, do I run in OpenFlow mode or P4 Runtime mode? So this was something we released this June, and also, of course, on the Tofino hardware. And then what we're doing for this September now is that we're actually taking our security load balancer solution and refactoring it from OpenFlow to P4 Runtime. And this is planned for this month. And so to do that, we had to create this Novi P4 Runtime speaker. So we had to create a little piece of software that would talk P4 Runtime to the switch, and then we put the application on top of it. And so that's slotted for this September. So, and just a couple of things about the CyberMafia. So it's a security load balancer using Tofino white boxes. So it gives you load balancing at terabit speeds, you can scale the pool dynamically. Add, remove resources. We use Tofino white boxes, and then we can do offloading of whitelist and blacklist, etc. But we're targeting security tool farms. There's analytics built in and management that will give you, for example, latency visibility in the tool farm and other things. But why are we doing this, and what were we expecting out of this refactoring of OpenFlow to P4 Runtime for this application? So we had three areas that we were hoping for. The first one is we wanted to be able to use the silicon more efficiently. So when we were using the Tofino silicon through the OpenFlow paradigm, we had to add a lot of and allocate resources for things that the application didn't necessarily use in the silicon. So that's one big thing. CyberMapper now, there's a very specific P4 pipeline defined for CyberMapper that doesn't have anything to do with OpenFlow. It's a match action, but it's not tied to OpenFlow. So we expect, and what that means is that we're going to free up TCAM and SRAM resources. And why is that important? Well, that will give us more memory to do flow entries, wildcard and exact match. And then the second thing is that we hope from this refactoring is that it will give us a faster time to market for new features. So in the old paradigm with OpenFlow, if we wanted to create some new functionality and it wasn't within the OpenFlow protocol, we had to create an experimenter first and then build the application on top of that experimenter. Now we can create a new pipeline without having to change the protocol between the controller and the switch. And so we expect a faster time to market for us to do. And then the third bullet, of course, is, and a good example, right, before we move on, new features. So let's say we want to implement SRv6 in our CyberMapper, or like a gateway GTP to SRv6 for mobile networks. If we had to do that in OpenFlow, we then had to create all those match fields, all those new push-pop actions, all those, and other actions. Whereas if we do it in P4 natively, we just define it in the P4 code and not having to change the protocol between them. So that's important. And I have some examples over there. Imagine you have to do segment routing. You have to add a SR header, and if you're doing a masquerading proxy, you have to add another one. And you can't do that in OpenFlow, unless you add those facilities through the experimenter. So, and then the last thing is, it gives you more freedom in defining new match action functionality. So in OpenFlow, we were always constrained by this OpenFlow only paradigm. That and that's the paradigm we were working in. So in the switch, you didn't have any autonomous functions or and the examples here I have is L2 learning and ARP learning, right? The OpenFlow, to do even the simple L2 learning, you actually had to send the information up to the controller, and then the controller would add a flow entry in the learning table. And with P4, we can actually create that autonomous function in the switch. And there are a lot of examples of those kind of autonomous functions that could be very beneficial. So sum up, we believe, P4 and P4 Runtime is really the next generation of programmable match action pipelines. And that's it. Thank you.
Was there anything that you found that was either you couldn't or was really difficult to map from OpenFlow into P4?
Yes. Yeah, there were certain things, like I mentioned, we could only do 5 out of the 6 instructions in OpenFlow. And so the 6th one, there were some things we just simply couldn't do. And I'm going to go back and see which one it was. Clear. Yeah, the clear action, right? So, and the other thing that we found was that going from the MP to the network processor to FINO was that we had to create these chains of functions. So when we auto-generate that P4 code, we had to build like blocks of multiple functions to make it, to be able to do it. And that put constraints. So OpenFlow was actually even more flexible because of that. But it didn't really, that wasn't a big deal. But the big thing that we saw, and that really is pushing our conversion to native P4 and P4 is the resource usage. So when this mapping was not very efficient. It was possible, but by writing the pipelines natively in P4, we can make them more efficient in regards to resources. So.
I have a follow-up to that.
Okay.
So in OpenFlow, you can provide an action list, and in P4, you're restricted to one action. So do you compute for instructions and actions kind of a cross-product, or how do you support action lists?
Yeah, so I don't know. Sorry, I'll find that out. So I think that was one of the issues we had as well, that you couldn't create the action bucket, and that goes back to this clear action, right? So that's clearing your bucket of actions. Mm-hmm. So there were limitations in that area, but I don't know exactly.
Cool, thanks.
Yep.
And one other question around this is, how do customers specify the OpenFlow pipeline? Is it using a TTP, or what is the format?
Yeah, so you can do it through the CLI or through that command. Okay. And we have one customer in particular that absolutely pushes the new pipeline through that command, OpenFlow command. But you can also do it through the CLI.
Okay, cool, thanks.
So do you plan to continue to develop your OpenFlow interface as well? Going to move to 1.5 and?
Yeah, so we started building some of the 1.5 features, but we really have stopped. And,
so you're going to go
yeah, I think we're done.
P4.
The INT that I just mentioned, the INT, and we actually did INT and postcards. At least the INT in OpenFlow, but we're getting to the I don't know how much more development we'll do on OpenFlow. Yeah.
Other questions?
Did you compare the speed with which you can program the flows with OpenFlow? Well, the speed with which you can program the flows between P4, native P4 to OpenFlow.
So what's that? Can you repeat the question?
Like how fast you can program the flows with just P4?
Oh, how fast can we convert?
Yeah.
To P4?
Right.
Yeah. So we finished phase 2 in June, which was the switch. And then we expect to finish the application and the controller in September. So it's not a very long time. And I should also say that so inside CyberMapper, we use a very basic OpenFlow controller. It's not an ODL or ONOS or very complicated controller. It's a very simple controller. So what we're essentially doing is, from an application point of view, we're swapping that out with a P4 runtime speaker, and we already got much of the functionality working.
So maybe
we're not that worried about it.
Maybe I can try restating the question. So from an API perspective, if you were to push like 10,000 or 100,000 write requests via OpenFlow versus P4 Runtime, are you observing performance differences between the two APIs?
No, we're not that far along. We don't know yet. So I can tell you on the OpenFlow side, we can get all the way up to 40,000 flow entries per second on some of our platforms, but we don't know any numbers yet for P4 Runtime. What I should say though, the CyberMapper application or the CyberMapper solution that we're building is not that intensive. You don't change the rules that often, so it's not going to be constrained by the P4 Runtime throughput.
Other questions? All right. Oh.
Is your methodology going to be made public? So you're going to open source your method of getting from OpenFlow to P4? I imagine other companies might want to do that as well.
To make public what?
The way your conversion between OpenFlow and P4, is it going to be kind of open sourced? Is it going to be documented? Is it going to be made public to the rest of the world? Is it secret? It's a secret then?
No, I don't think we will. Yeah. Yeah. So are you interested in that conversion mechanism? How we did it? Yeah. Okay. Let me think about that.
Talking about the hybrid one? Yeah, there must be other people out there who want to go through the same process, you know.
Right. Yeah.
Let's thank Jesper.
Yeah, let me think about that. Thank you.